Tomorrow, Tuesday, PSAT. So that involves most of you, not quite everybody. If you're a senior, you're not taking the PSAT, so you get a day to work at home with no classes because all us teachers can be busy with the PSAT, so we will not be having our class tomorrow. So no classes on Tuesday because your teachers will be all busy, unless you get an email from them. Otherwise, one of them got out of it. But most of us are busy with that. So I would expect you, if you're a senior, you'll just have a nice day to get caught up on some things. But all the rest of you that are sophomores and juniors, be sure and check the spreadsheet that I posted to Google Classroom. It will have where you're supposed to report to. It'll be at BHS or at West. There's locations both places, so be sure and check that to see which location you are supposed to be at. So from that sheet. This week in Algebra 2, let's see what is due. I rearranged it a little bit because I think we got a little bit of more time than I thought we might have before the Christmas break, another week or so. So what I have due this week is 3.06, 3.07. I was originally going to have 3.08 this week. I've pushed it back, and next week we'll do 3.08 and the practice test, and then we'll have the actual test the week after that. So, do Halloween. Yes, Simon's do Halloween this time since it's Sunday. But don't wait till Halloween. You don't want to be doing math instead of out, eating candy. Guess you could do both. You could eat candy while you do. Well. Do Halloween 3.06, 3.07. So hopefully you are current and you've got everything done up until 3.06 and 7. But those two lessons go great together because the second one, there's nothing new. The second lesson is made to give you more practice in more situations to make sure you understand it, because this is something that we do a lot in math, and it's solving quadratic equations. So this week in 3.06, we're going to look at this, solving quadratic equations. Also have a story I added in Buzz about the quadratic formula. So you can see that it's a little like 4 or 5 minute video that I put a story from Dr. Chen about the quadratic formula. Dr. Chen was a professor I had back in college, long retired now. I'm sure he's no longer teaching, but back when I was a young man in college, and the story, I've remembered it ever since. It stuck with me. Love the story about the quadratic formula. So it's in Buzz for your viewing pleasure. So if you want a little chuckle, you can see that, and that's where a lot of my opening from my video comes from too. I pull a lot from that video. All right, let's look at this. So what we're learning is methods used to solve quadratic equations. And then the other essential question we have is how are the solutions, roots, and x-intercepts related of a quadratic? I'll give you a hint. They're basically all the same thing. They're all the zeros. The roots is the zero. The solution is the zeros. The x-intercept is the zeros. They're all the same thing. So little hint there. So there's lots of ways to solve a quadratic equation, depending on what equation looks like, what your quadratic equation looks like. So let me open up my camera. All right. Solving quadratic equation. One way to do it is by factoring. Let's look at if we had x squared equals 9. That is a quadratic equation, actually. It's just written to be equals rather than all be on the same side. So we know that we can solve that by, well, we could take the square root, right? We can take the square root of both sides. So that would be x. And the square root of 9, there's 2 answers because there's 2 different numbers that can be multiplied together by itself to be 9. So that is plus or minus 3. So there's two solutions to x squared equals 9, because either x would be 3 or it would be negative 3. So we know that. Another way we could solve that, though, is if we had x squared equals 9, we could subtract 9 from both sides. We've got x squared minus 9 equals 0. X squared minus 9. For those of you who were paying attention a couple of lessons ago and remember this, this is the difference of perfect squares. Difference of squares, right? So x squared is a square number, 9 is a square number, difference of squares, which means we can use our pattern. It says x and 3 and 3, one of them positive, one of them negative. We just factored it. We factored it using our difference of squares. And so if x plus 3 equals 0, which is one of the options, or x minus 3 could equal 0, subtract 3 from each side or add 3 from each side, and x equals negative 3 or x equals 3. So we get the same thing we did doing it this way if we moved it all set equal to 0 and factor it. And we factor it using difference of squares. So to check those answers, we would want to just take negative 3, substitute back in. Negative 3 squared equals 9. Does that equal 9? Yes. Negative 3 times negative 3 equals 9. And by the same way, checking to see if 3 squared equals 9. Yes, that works also. So both of those answers are correct answers. They both check out when we substitute them back in. So fabulous thing. By the way, I don't know if you've noticed this on Buzz, and I'm assuming yours has done this too. I'm gonna share this with you because I just noticed this today. I don't know when this update happened. At some point, there was an update to our Buzz, and if you haven't looked at it, over here on the right-hand side, there's this little icon. It says click and hold to drag the toolbar. There's this toolbar that you can put wherever, I guess. When I click on the little arrow, I have these options over here that are new. I have not seen these before. So this says select this button and click anywhere in the text just to start reading aloud. So if I click on that button and say right there.
Now, what does this mean graphically? To answer this question, graph the equation x2, 9 equals fx.
Okay, so it's not real good at saying x squared. It says x2, but that's how you can read. This will read everything for you. So you can click on the button and just choose where you're going to start, or you can just go to the beginning, and if you just hit the play button, it just starts reading everything on the page, which will even read like Algebra 2, factoring in quadratics 2.06. You know, you may not want that. Use the little finger and tell where you want to start. You can click right there.
While redesigning her backyard to build a pool.
Pause it. Stop it. So kind of interesting. Got some settings you can change. You can make the voice slower or faster. The highlight color. You can have it hover or click to go into speech mode, and you can have it translate if you'd rather have
translations.
If you want to,
by
yes.
translating
Stop reading.
from.
Stop reading. Stop reading. Stop. Let me undo the finger. Okay. So you can have it translate into different languages. Got like 10, 11 different languages there that it can translate. So you can have it translate and read to you. So something new there. This is make a selection page. Click this button to translate it. Make a selection and click the button for dictionary definition. So if you click on that and say, what is knowledge? And then I'll click on that. Knowledge, it's noun. It's all the information and skills you have on something. Her knowledge of English is limitless. So you can have words defined over here. A picture dictionary definition. So there's the Pictionary, the picture definition of knowledge. I love it. So just some new options that are there in Buzz I thought were interesting. So if anyone would like to use those, needs to use those, Buzz has upgraded and given you more capability now. So that's kind of cool if you're getting to some places where you might want to use that. So okay, so let's move on with our solving quadratics lesson. Talks about, says, do you remember the factor tree? So it's got this little illustration it puts in our lesson of this tree, and it's got all these different trunks up here. This tree, all this bushiness, this tree up here. It talks about methods of factoring because there's many different methods to factor. Methods of factoring. So with the quadratic methods of factoring, we can find the greatest common factor, right? That's one of the things we do is we find the greatest common factor. We look for perfect square trinomials. Perfect square trinomials help us factor. The difference of squares, which we already used up above on this page. Difference of squares helps us in if it's squares and if it's a perfect square trinomial. Grouping and factoring. All right, so we can have grouping and factoring in trinomials. We can complete the square. All these are methods that we use in factoring quadratics. Right, so if we're talking about, let's talk about quadratics specifically. Okay, but to get down here to the roots, right, the roots is the solutions, right, we have to go through the discriminant. Discriminant. I don't know that I wrote that very clearly. A-N-T. The discriminant. And the discriminant is that part of the quadratic formula. B squared minus 4AC. That's called the discriminant. And it'll get you down to the roots. And the discriminant will let you know what kind of roots to expect. What kind of roots to expect? Are they whole numbers? Are they imaginary numbers? Are they not rational numbers? Are they irrational roots? Using the discriminant will help us get down to figure out what kind of roots that we have there. So let's look at a nice example here. Let me choose one. By the way, this has multiple examples, and some of them, it solves them different ways, including it gives you videos. There's several videos in this lesson. Most of them, some of them 15 seconds long, some of them like a minute and a half, 2 minutes. So this video I'm looking at on page 2 is 14 seconds. Yeah. Step 1, it gives you factoring, solving quadratics by factoring. So let's say, so it gives us this problem here. 6x squared equals 33x minus 45. Okay, so we have this to solve. We need to find the roots. We need to find the zeros. We need to find the x-intercepts. Those are all words for the same thing. So to do that, I'm going to do the factoring, which means I'm going to move everything to one side. I'm going to subtract 33x and add 45 to both sides. Now, I could do those one at a time if I want to, or I can just do them both at the same time. It really doesn't matter. Well, as long as I do them correctly. Okay. So I moved everything over here over to be with the quadratic. I like moving it this way because I like to keep this a positive number. It's just easier to work with if that's a positive number. You can go another way. So I want to look for the greatest common factor first. 6. 6 will not go into 33. So we can't use 6. But factors of 6 are 2 times 3, right? So 3 will go into 6. 3 will go into 33. 3 will go into 45. So let's factor out a 3. That leaves us 2x squared minus 11x plus 15 equals 0. Okay, so I'm getting closer. Getting closer now. So now I need to factor out this, right? So I need to find what are the factors that multiply together. Going to be 2x and x. And 15 is going to be either 1 and 15 or 3 and 5. But let's multiply the first and the last coefficient together. So it'll be 30. Right, so what are the factors of 30? 1 and 30, negative 1, negative 30. 5 and 6, negative 5, negative 6. 2 and 15, negative 2, negative 15. 3 and 10, negative 3, negative 10. I think that's it. I don't think I can multiply anything else to get to a 30. And we need to get to a negative 11. So if we add these together, which one gets to negative 11? That gets us 31. That gets us negative 31. That gets us 11. Oh, that gets us negative 11. Don't need to go any farther than that. So negative 5 times negative 6 will get us what we need. But we've already got a 2 in there. So we have to figure out 2 times what. We don't want to do the fraction. So the negative 5 is going to go with the 2. And what will get us to 6? Negative 3. Remember, we have to multiply. These two numbers have to multiply together to equal this one. So 2x minus 5 times x minus 3, and we still have the 3 up front, equals 0. This is the factored version of this. And there's a video on this, so they may factor it differently. There's different ways to factor. All right, so watch the video and see how they factor it if this got a little confusing. So now we have to set all these equal to 0 and solve. So first thing we set is we have the 3. That's one of the factors. 3 equals 0. 2x minus 5 equals 0. And x minus 3 equals 0. Okay? Because if all these are multiplied together and equal 0, that means any one of them could be a 0. So 3 equals 0. Is that ever true? No, 3 will never use it. So we have to throw that one out. That is not a solution. 2x minus 5. Let's add 5. So 2x equals 5. Divided by 2. X equals 5 halves. So x equals 2.5. 5 halves, 2.5, however you'd like to say that. Add 3. X equals 3. So our two solutions are x equals 5 halves and x equals 3. So if we graph that, we would expect that would be the x-intercepts. That's where this quadratic equation would go through the x-intercept at 2.5 and at 3. So they have lots of examples on solving quadratics by factoring. They have some by completing the square, different ways to do that. Let's go. Excuse me. Excuse me. So that talks a little bit about the history of the quadratic formula. Goes all the way back to the ancient Greeks. The ancient Greeks laid the foundation for a lot of the math we use today. And they started looking at rules and formulas that would work for every situation instead of having to calculate everything every time. It's like there's got to be some formulas, there's got to be some rules and things that we can just apply every time in a certain situation. So from that, they discovered the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and that is when the quadratic is in the form ax squared plus bx plus c equals 0. So we have to have our quadratic equation all on one side of the equal sign and equal to 0. And that gives us our a, our b, and our c to use in the quadratic formula. Now, here's the nice thing. If you struggle with factoring, if you struggle with completing the square, if you can't do a good job with a lot of the different ways to factor quadratics, this always works. The quadratic formula always, always, always works to solve a quadratic equation. And it will give you rational real roots. It will give you irrational roots. It will give you those imaginary complex roots. So it will give you all of those right here. So the really cool thing is for a quadratic, if we break this apart a little bit and I say, all right, I'm going to look at this part right here. Negative b over 2a. x equals negative b over 2a. This will give me the line of symmetry, the axis of symmetry for this parabola. Because when we graph this, right, it's going to be a parabola. And there is a line of symmetry that runs right through the middle of it. It works like a mirror, that this side looks exactly like that side. And the equation to find that is right there. That will find what the equation is for that blue line. X equals what? So we just take the B, put it on top, take the A, put it on bottom, multiply it by 2, and it's negative whatever those numbers end up. And that will give us our axis of symmetry. So after we have the axis of symmetry, we can find the vertex from that also, because the vertex is that point. We can take whatever that x is, substitute it back into the equation and find out what y is. And then this other part we talked about is the discriminant. The discriminant, that's what tells us whether the answer we're going to have is a complex number that's imaginary, or if it's a whole number, or if it's going to be an irrational solution. All of that is based on the discriminant. So we use these pieces for different things, but the whole thing will give us the roots, give us what we need to know. So, and there's videos that step through this too. So watch these videos. There's plenty to find in this lesson that is really, really good stuff. Really, really good stuff. And there's lots of summaries, information on all of this. So when I look at the lesson review, it talks about make sure that you know what methods can be used. Steps, it gives you the steps. So if you want anything put in your notes for the test, write down these steps. So write the equation in standard form, which this is the standard form. Factor it, set the equations equal to 0, and then solve it. Check the solutions. Those should be in your notes for the test. So let's look at steps for solving using this quadratic formula. We got this quadratic formula. Let's use it in a problem. So I'm going to put it right there at the top, and we're going to put this right there. So we'll do this. All right, so I've got this equation. 3x squared minus 12x equals 27. All right, so the steps to solving is first, write in standard form. Standard form. Standard form is this, where everything's set equal to 0, which means we need to subtract 27 so that I've got 3x squared minus 12x minus 27 equals 0. Now it's in standard form. So now I can factor it using whichever method I want. I can try to factor this, pull out the greatest common factor. I can complete the square. I can do all those things. But I'm going to use the quadratic formula. I've got the quadratic formula. I've got it in standard form. So my A equals 3. My B equals negative 12. And my C was negative 27. So let's plug that in to find out the solutions here. So negative B. Well, B is negative 12. So negative 12 is a positive 12. Plus or minus. B squared. Negative 12 times negative 12. That's a positive 144. Because when we square something, it's going to be positive. Minus 4 times A. A is 3. And C is negative 27. And all of that is going to be over 2 times A. 2 times 3. Okay, so now I just need to simplify. I've got all of this underneath that. So x equals 12 plus or minus. Let's do the math. 144. This is minus 4 times 3. I'm going to pull the calculator out here just to save us some brain power, because we have to do this negative 27 there. So negative 4, I'm going to multiply all these together. Negative 4 times 3 times negative 27. So the calculator tells me that's a positive 324. Positive 324. And all of that is over 2 times 3, which is 6. Okay, continuing to simplify. 12 plus or minus. What's 144 plus 324? 324. 468. So the square root of 468. So let's take square root 468. And that says it is 21.63330. So we're going to round it off. 21.63. We'll go 2 decimals over 6. Okay. So that means there's 2 different answers because it's a quadratic equation. It should be 2 answers. One of the answers, x equals 12 plus 21.63 over 6. And the other one is 12 minus 21.63 over 6. Now, most of the time, 468, they're going to have you leave this. What am I looking at? Oh, I didn't do that first. I'm going to have you leave this as a square root of 468 rather than putting a decimal form. But I think I've made this harder than it needed to be because we could have factored out a greatest common factor at the beginning. We didn't do that. So we'll come back and see if that changes our answer. All right. So if we solve it as it is, this is a good experiment to see if this changes our answer. 12 plus 21.63 divided by 6. So our answer is about 5.605. And this one where we have canceled, hit the wrong button. Okay. We have 12 minus 21.63 divided by 6 is negative 1.605. Okay, that's the 2 answers we got. Now, I skipped a step that would have made this a lot easier on us. And I'm going to see if it changed our answer because I don't know right off the bat. Let's go back to the beginning with our original equation. Okay, there's our original equation. Greatest common factor. 3 can pull out of all of those. 3x squared minus 4x minus 9. So now factoring this using the quadratic formula, our A is 1, our B is negative 4, and our C is negative 9. I want to see if this changes our answer by leaving that 3 in there and not factoring it out first. So x equals negative B, all right? Our quadratic formula, negative B, at the top. So it's negative 4, so it'd be a positive 4 plus or minus the square root of B squared. Right, negative 4 squared is 16 minus 4 times A is 1 and negative 9. All right, so that's negative 9. So now let's go down and see what this is. And 2 times 1, so it's just 2 in the bottom. So let's simplify. 4 plus or minus. What's under here now? 16. Negative 4 times 1 is just negative 4. Negative 4 times negative 9 is a positive 36. So this is 16 plus 36 over 2. So 16 plus 36 is 52. This is the square root of 52. All right, now square root of 52, we can factor that down because 52 is 4 times 13. So they would generally just want you to simplify the radical in this case. 4 times 13 is 52. The square root of 4 is 2. So this is 2 square roots of 13. So they would say the answers are x equals 4 plus 2 square roots of 13 divided by 2, which this will simplify down because 4 divided by 2 and 2 divided by 2. So this equals 2 plus the square root of 13. And then over here, it would equal 4 minus 2 square roots of 13 over 2, which would simplify down to 2 minus the square root of 13. So now let's evaluate what 2 plus the square root of 13 is and 2 minus the square root of 13 to see if it's anything close to what we did when we converted it to a decimal. We'll see what effect it had on us by not taking out the greatest common factor. So 2 plus the square root of 13 equals, look at that, 5.605. Well, actually, it would round up to a 6. Yeah, we're off by 1 in 100 just because of a rounding issue. And then 2 minus the square root of 13 is a negative 1.60. Again, rounds up to a 6. Okay, so it does not affect the answer if you don't take out the greatest common factor. But look how much easier it was to deal with these numbers rather than multiplying by a negative 27, and we're up here in the hundreds as opposed to just 52. So it just makes more work on yourself to not pull out that greatest common factor, but you still will get the same solution. Like I say, this is off by 1/1000th just because of a rounding, but that's essentially the same answer between those two. So the quadratic formula always works, But look for that greatest common factor, because if you can pull that out of there, that will save you some time. So that is the big part of 3.06. I'm not doing a lot of examples of the completing the square and the other factoring, because that's what we did in earlier lessons. This is really about using more of the quadratic formula. And really, this lesson is all about looking at all the different ways together, 3.07 is all about practicing different ways. You can do this, complete the square. You can do this by factoring, pull out this greatest common factors, use the quadratic formula on this one, all these different things. So 2 really good lessons with plenty of practice for you to get good at solving quadratic equations. Going through there, trying it, clicking to see if you're right, trying the next part, and it'll walk you through. It'll say, first, find out the greatest common factors. Okay, let me do that. Click. Okay, those are right. Now it'll say factor this equation. So now I factor it. So step by step by step, go through these lessons, step by step, look at those things, try those examples, make sure you have pencil and paper in front of you, and you're trying these ahead of letting Buzz just tell you the answer. Because when it sits there and tells you the answer all day, you don't remember much of what happened. Just doesn't work. We learn math by doing math. That'll be my mantra this year, because we get lazy online. We do. When we can just watch the answers on a video, when we can just click and get the answers, we get lazy and we don't learn math like we need to. So, all right, I'm not going to throw anything else at you. You got PSAT tomorrow for most of you. Like I say, the seniors don't. So I will let you go. If you have questions, hang around. Otherwise, have a great week.
Let's get out of here. Word to your multiples. Math, baby.